Okay, so sometime last summer, I decided I wanted to do a native app. I sort of knew about ObjectiveDDP because it come up in one of my many web searches for bits and pieces. I started to develop a native version of this, of our product, IDrive. In August, early August, I was at a point where I wanted to take a break from iDrive completely because I just had my head too into it. And I suddenly realized I had all the pieces to do something, a sort of pet project that I'd wanted to do for a long time, to do with another iOS product I had, and I used Meteor for that. And this was one of those cases where Meteor worked perfectly, because with a combination of ObjectiveDDP and the Meteor server, I went from an idea in my head to working product in 2 days. The Meteor server side of it was about 100 lines of JavaScript. So, and it worked great. It's a little bigger than that now, but not much, and the core is exact same. So I'm going to talk about ObjectiveDDP and how you use it in iOS on top of Meteor. There's a little bit of code in here. It's mostly like API signatures, and it's an Objective-C code. There are, on the ObjectiveDDP Git repository, there's lots of samples, and they have Swift samples for people who want to do Swift. So if that's your sort of your bent, that's there. And there's also an Android version of this. It's a totally different maintainer. It's a different group of people, and it has different features. And I can't really talk about that in detail yet because I haven't gotten into it. So native, for me, easy access to iOS services was a really big reason for doing this. We needed in our product to have full, deep integration with the calendar, with the contacts list. At some point, maybe with the GPS, certainly with the internal mapping system. It's a whole bunch of stuff we wanted, and it just looked like it was going to be really a lot of learning to do this any other way than native. Native look and feel, so getting all direct access to gestures and rotation and all of that stuff. We wanted an offline mode. We haven't written it yet, but it's absolutely in our roadmap. And so the ability to persist all the data that was coming up from Meteor and be able to use it when we weren't connected to the server. And that's really tough in a web app. It's not impossible, but it's really tough. And the other reason is, in the case of my other project, which I will talk about later, I had an existing fully blown Objective-C application that was in the market. And there was this cloud piece I wanted to add to it. And having it being a reactive data sync was like absolutely perfect for this. So taking a very large existing code base and just adding this functionality, that was a huge pro. Cons, second code base, right? I'm currently living the not dream of a full-blown JavaScript Meteor solution that's running our web presence and an Objective-C one, and pretty soon I'll be running a Java one that runs the Android presence. You don't get hot push, so if you make major changes to your database schemas, you're going to be spinning the app and resubmitting it to get it re-released and get people to upgrade and all that other junk. And you don't get a reactive rendering engine like Blaze or React. Right? You have to deal with your own UI and know when things changed and decide what you're going to do about it. So those are the sort of the pros and cons. And actually there's pretty big cons as well as pros. Okay, so I'm going to talk about really 3 pieces here. I'm going to skim 2 of them. The off-the-shelf stuff is Socket Rocket, M13 Ordered Dictionary, and ObjectiveDDP. ObjectiveDDP relies on those first 2. The ordered dictionary is so you can get essentially JSON objects in order and not have them get mangled in terms of the order they're in, which DDP really likes. And Socket Rocket is the underlying socket connection that ObjectiveDDP uses to run the DDP link. And then on the other side, the custom stuff is a bunch of layers that I built on top of them, called Collections Manager and the Mongo Converter. Okay, and as I mentioned already, this stuff's the DDP stuff has examples in Swift. So if you want to do this in Swift, it's not a big deal. Okay, so off the shelf, ObjectiveDDP implements the DDP protocol that sits underneath Meteor. All right, so this is the socket itself, the ping pong of keeping the connection alive, and all of the protocol for doing subscribes, data changes, all of that stuff, right? It uses the M13 Ordered Dictionary to be able to handle extended JSON like Meteor does, and Socket Rocket for the actual sockets, right? So there's a bunch of stuff that comes with that, and I'll go through that really quickly. So user management. So they have APIs in Objective-C, and these are basically Objective-C fingerprints or API prints. To do sign up, sign in, sign out, And I'm not showing all of them. There's tons, right? There's stuff for doing OAuth, like Facebook logins in the library. There's lots. And you sort of pick the ones that work for you. We're using several of them in ours. We're not doing the OAuth stuff right now. Okay, so that's sort of user management. Subscriptions for getting data in, right? You have add subscription with just a straight name and no parameters, and with parameters, and remove subscription, which is something that most Meteor people don't do because they're using a router that does it for them automatically. But the ability to close down a subscription once you're done with it is in here. Okay, so again, this is all in ObjectiveDDP. Credding, so you can do any kind of Meteor call that you would do with a method name using that top API, right? So you have a method name and you pass an array of all the parameters and you get a callback. You can also do direct credding to the database using the patterns that are down here. We don't actually do this at all in our product. We're using everything as in Meteor calls so we can do all the secure parameter checking, but this lets you do direct inserts, removes, updates to the database, upserts, and you can do anything you want that you would be able to do in Meteor that way. Okay. Reactive changes. So when a subscription happens, you'll get callbacks, right? And they do a notification through using the iOS's notification system. So you just basically register as a listener, and when these things happen, you'll get called. You'll get parameters to tell you exactly which subscription is ready, and you can deal with that. And then the last thing on this page is added, changed, and removes. They have 3 different notifications for those. So if you guys haven't done lots of Meteor. So when you do a Blaze template, it automatically puts listeners on the objects that you're listening to, so that if they change, it does the re-renders of the page for you. But there is a thing in Meteor where you can add a listener to any database query and get those reactive notifications to manage them yourself. And that's essentially what you do with ObjectiveDDP. So you can get, this collection had an element added to it, had an element removed from it, had an element changed in it. And you can listen to all of those. Okay. Sorry, that's one more thing. So everything that you get out of ObjectiveDDP comes in as an M13 order dictionary, which is just a dictionary, which is essentially a JSON object, right? I mean, it's been rendered down into an Objective-C object, but it's essentially a JSON object that you can then poke at. That's fine, but when you want to actually deal with it as structured data, it's not as great, right? Because if it was JavaScript, it would be really easy just to poke around at it, but because it's not, you have to sort of know the structure in order to be able to interrogate it and pull the data you want out of it. And that's kind of one of the things that I wanted to solve. So, a few sort of gotchas with ObjectiveDDP. When you log in, it doesn't automatically subscribe to the user. You actually have to, which Meteor does for you. It's sort of built into the templating system, but you actually have to remember to go in, once you've got a user ID back from the login calls, to go and subscribe to that user so that you get the profile data and do stuff with it. When the connection the connection will reset when your app goes into the background because it's not pinging. And when you come back from that, Meteor is going to go and assume that you're really out of date and resend everything you're subscribed to. It does reconnect beautifully. I wouldn't have said that a month ago, but over the last month I've solved that problem, and it was mostly I had written too much code, so I took some stuff out and it was cleaned up. I was trying to deal with the reconnects myself, and I shouldn't have been. So this thing handles the reconnect very nicely. Objective-C, in Objective-C, a Boolean is just a number. It's not a special type like it is in JavaScript. And if you just say, I've got an endless dictionary and it's got a Boolean in it, and you encode it as a JSON, sometimes it'll encode as a Boolean true-false, and sometimes it'll encode as a number 0, 1. And that can really mess things up if you're expecting it to be one way or the other. So there are ways to force the dictionary to encode it properly, but you got to really pay attention when you're dealing with Booleans. And that's just one of those things when you're bridging between languages, and languages have different properties, you can run into issues. And the other one is that eJSON uses custom escape sequences for storing dates and base64 data. So if you're storing, base64 or encoded images for an avatar, for example, those don't come across the wire as images. They come across the wire as really big hex strings that you have to then detect in the JSON and convert back to image data. So if you're just dealing with ObjectiveDDP at that level, there's certain things you have to be very aware of and do yourself. And I didn't want to, so I solved that problem. So Collection Manager. This is native code that was developed to make ObjectiveDDP work better in the environment that we were playing in. Over the last month, it's been made really generic, such that it might end up being pushed either with or beside the ObjectiveDDP Git, so it's an open source project. I've started talking to the guy who runs the ObjectiveDDP. He's the maintainer, and he's sort of open to that. So I'm supposed to talk to him again after I do this presentation. So this thing wraps the ObjectiveDDP Meteor client. It handles the user subscription for you. So when you log in, it will automatically go and do that subscription and expose the user profiles for you. It supports subscribing to an array. So in Meteor, you can say, you can pass a single subscribe as a subscription, or you can pass an array of subscribes in your router. And I found the array of subscribes to be very useful because it's whenever you're dealing with complicated data, you're usually subscribing to multiple things. And so it wasn't built into ObjectiveDDP. It is in Collection Manager. And Collection Manager aggregates all that, waits for all of the internal subscriptions to finish, and then it sends you one notification to say it's all here. It converts the MongoDB data that's coming in into core data, which is really nice because you can now persist it locally in an SQLite, or you can persist in any backing store that you want to use in iOS, and you can start treating all of this data as just objects. So you don't have to start tearing apart the dictionaries to get to stuff because it does it for you. It provides a bunch of Mongo-like find methods, so find and find one, that turn around and go through the SQL, build the predicates to be able to pull the right data out of the database and return the stuff you'd need. And it also automatically handles the eJSON escape data types. So those dates and base64 stuff, it handles all that for you. Okay. So construction, there's a singleton for this generally, and you can have it without a singleton if you want. So if you were, for some reason, connecting to multiple different Meteor instances, you could do that. But the singleton's just much more convenient. And you basically give it the managed context, which is the pointer to your database, so that it has somewhere to actually put all the data once it gets it. Okay. Anybody wants to stop me and ask questions, please do. Okay, because I'm going to go as quickly as I can. Once you have a collections manager, if you want to start Meteor, you just call start Meteor. And you pass it the URL for the site, right? And this is the exact same URL that ObjectiveDDP would use, so it can include the version of DDP you want to call. It can include whether you're using secure sockets or not. All that stuff's embedded in this. And once it's started, then you call connect to actually make the DDP stuff happen. For managing users, it provides accessors to get access to the user ID and the user profiles. And it provides a logout method for actually just throwing it all away. So this is all at the collection manager level. So a lot of this stuff's been abstracted. Subscriptions, there's two APIs for this, right? This is the traditional subscribe to one thing, which is still useful. And there's a subscription object that you create that has the information about what it is you're subscribing to and the parameters and stuff. The notify is the string you want back when it's done, and then you give it an object and a target method to call once the subscription's ready. And then the subscribe to array is the exact same thing, except it takes an array of subscription records. Okay. And then the last piece here is you can unsubscribe, passing that exact same notify string back in, and it'll actually do all of the unwinding for you. So if you have a subscribe to many and it's got 5 or 6 subscriptions in it, you just pass the one string back to it, and it'll turn off all of the subscriptions and free them all for you. So that's quite nice. Okay, reactive events. So the collection manager has its own notification center. So rather than using the OS's default one, it does all of its broadcasts of stuff happening on a private one. And this is extremely important for one critical reason. If you start listening to the ones that are coming out of ObjectiveDDP, you may get notified of events happening, new objects coming into the system, before the collection manager has a chance to convert them into core data. So you could get a notification saying, this record has been, or this document's been updated, and you go looking for it, and the data you get hasn't changed yet because it's still the old copy in the database. Because it's very hard to sequence, know exactly who's going to get notified in what order with the default notification center. So essentially what this one does is it'll consume the stuff that's coming from the notification center, do the conversion, and then forward it to you. So we do all of our listening through this one, and don't worry about the one that ObjectiveDDP runs. Okay, but it's essentially the exact same thing. You pass it the same kinds of parameters, and it will tell you when things are ready. The one other change is when the object ID comes as part of the notification. So if you get a new element's been added, or an element's been removed, or an element's been changed, the payload from this notification will be the ID string for that object, so that you can immediately go back into the database and query for it, grab the record out of core data, and start working with it. The other one it has is a nice little helper shortcut where you can ask for all notifications from an object, which gives you both the added and then the changed. So because there's an awful lot of times when you need to actually pay attention to both of those. And especially when you go into the background and come back, because essentially the data is going to come back to you as added, which is going to reinstantiate all of your core data objects. And if you're pointing to the old ones, because you've got a retained pointer to them, you'll be looking at stale data for sure. And really bad things can happen when you do that. So I tend to use all, and then use the IDs to filter to the stuff I actually care about. Okay. So that's just a shortcut. So you can listen to everything at once. Mongo-like finds. So that the whole thing we're used to doing with Meteor, where you just call find or find one, and you pass it. Yeah. The slide or one back?
The last slide there. So you're taking all the changes in the collection at once, and then you're filtering through it with the ID.
So you're going to get, the DDP is actually pushing, this document changed. Right? So if you have a collection called, posts, and somebody posts something new, and your subscriptions say that you should get a copy of that, then you'll either get a post added with the ID of the new record, or you'll get, if it's an existing post that's been edited, you'll get posts changed with the ID of the object, right? So you don't get flooded with this stuff. You get them when they happen reactively. So this is the reactive listener that you need to worry about. So because if you go away, right, you background the app, and you do something else, and you come back a couple minutes later, Meteor's going to see that as a hard disconnect, because you weren't pinging back and forth for that time. And it will recover by re-pushing all the data to you that you're subscribed to, which essentially means that stuff that you actually have in memory already, you're going to get new addeds for, because Meteor's assuming they've gone away, right? And if you have a retained pointer to the core data object, the old version of it, it might have been actually deleted as part of the new ones being brought in and replaced by the new copy. So now you're actually, it's not going to cause a memory fault because you've got a retain on it, but the data in there is not necessarily valid. And because we're converting Mongo documents into core data, you've got relationships instead of single entities, and those relationships could have all been nulled out, right? Because they're no longer connected to anything. When I get into the sort of the converter, that stuff becomes a little more clear. So it's really important that you actually treat, in some cases, treat an added as a changed, because there's a new copy of it in memory, and you better be using the new copy, not the old one. That's all. So the all is just a really quick way to pull those together. Right? Otherwise, essentially all you do in code is you do this add observer twice for everything you care about, and that's a waste of effort. So the library does that for you. All right, so Mongo-like finds. So this is sort of a hybrid between using a SQL database for doing your queries and using the Mongo APIs that we're kind of used to if you're doing Meteor, right? So these all return managed objects, and you call find one and you pass it the entity name. So in that previous example, you'd say find one quote post with an ID, the string of the ID of the post, and internally this will convert it into fetch, a fetch and a predicate, and do the DB query, get the object, and return it to you. So if you want to do something more complicated, where you're actually doing the predicate stuff, there's a version for that. You can do the find all, which is equivalent to just find, right? Find all with sort. So there's all sorts of different flavors of this, and internally it does the right stuff, creates the sort descriptors or whatever to do the SQ-like queries, and returns whatever's in the database. Okay. So this essentially it lets you, even though you're working in different languages, it lets you actually see your code as being the same as what's going on in JavaScript, because you have essentially the same queries going on. Okay, and then Mongo Converter. This was the trickiest piece. So this is the code that takes JSON documents that came out of Mongo and gives you core data objects. Now, because it's SQLite, you've got a rigid schema under the covers, and it's not actually building the schema for you. You do have a schema description that matches what's going on in your Mongo, and there's a plist, so an XML file that contains hints as to how to take the Mongo stuff and convert it. Some of those hints are things like, if I'm trying to create a post, this is the entity name in the database that would be a post object. So I need to create one of those and insert it into the database and fill it out with stuff from the dictionary. A lot of the mapping is really just automatic. You can look at a member name in the JSON and go, does the object support that member name? Yes, we'll just move the data across. So wherever humanly possible, it does it for you. And you don't have to have all sorts of records that say, the field that's called date is called date in the other one. And it does automatic typing, so it can predict how to convert stuff over, and lots of exception handling so that nothing blows up if things don't quite line up. Now there's a few things where doing that automatic conversion is impossible. One thing is that Mongo likes to put underscores in front of certain keywords, like the ID itself, and SQ does not allow you to have an underscore in front of it. It has to be a lowercase letter as your first letter in an SQLite. So there's the ability to tell the converter that this thing maps into that thing, and it'll do it for you. Basically, it'll read it and convert it. And it also converts nested objects in your JSON document into relationships to other entities. So it actually builds out the SQLite tree automatically based on the core data, based on the mapping tables. It handles the added, changed, and removed reactive events, so it captures them all from ObjectiveDDP and does all the updates as it happens. And it's pretty much, it's exception proof. So any of the places that, making a guess about what's going on between the Mongo and trying to convert SQLite will be trapped and logged. Usually it's not a long-term issue. So you build a core data model, I already said that. To create an SQLite version of the Mongo documents. You create a plist that does the mapping, and it's, like I said, it's relatively sparse, this plist. And the missing keys are automatically mapped, or they fail gracefully. That's also really nice, because if you've got fields that you just don't care about, and they're not in your they get published, but you don't really need to keep them, they just dropped. So that's very, very nice. And you get a sparse object. There's also an internal state. Sorry, a field in Mongo called state. Oh, that's just the automatic. That's just an example. There's a few other things that it does. It does tag some stuff so that if you create an object in memory, it'll mark it as doesn't exist on the database yet. So you can actually track things are new. They exist in your core data store, but they haven't been pushed out to the web, or that they've come from the server and they're copies of what was there reactively. So there's a few breadcrumbs and stuff that happen inside this object. The other thing it provides is any of the core data objects can have can adopt a protocol that supports optionally any of these three APIs. So after convert is really useful when you've got something like a base64 encoded string that you know should be an image. It needs to be turned into a PNG. So basically, after I've converted it and I've extracted the encoded string and I've got it as a data object, you can then work that and convert it into a PNG so that it's available in your object ready to go. Or anything else you need to do after convert. Before update is called when a change comes in. Because of the whole fact that you've got an SQL tree of entities that are all related to each other, if you just blow it away and rebuild it, you're probably going to leak like crazy in the database. So this gives you the chance to walk your own tree and keep it clean. And same with before remove. These basically do the same thing. And in all of my current implementations, before update and before remove, do exactly this. Before update calls before remove just to clean out any dependent objects in the database before the conversion happens. What I want to do longer term, and it's not impossible, is to be really smart in the converter so that it can actually walk the tree and replace in place all the objects. That requires a little more deep diving into the partial change records, which I don't have right now. Does that make sense? Okay. So I don't know if you guys, when you actually get, when a change happens, the only information you actually get from Mongo is the exact things that changed. Right? So if somebody changed, if you had a field, a date field in an object that was coming from Mongo and the date was updated but nothing else, then you'll get a record across DDP that says, for this ID string, this field of date was now set to this value. And that's all you'll get. Or this field was removed from the document, or this field was inserted into the document. So it doesn't actually send the whole document on a change, it just sends literally the changes. ObjectiveDDP deals with it under the covers and actually processes all the change records and updates the dictionary that it passes you. So once you get notified of a change, you've got the entire converted dictionary, not the individual steps. So to do what I'd like to do, I need to get in a little closer and actually do all of those conversions in real time into the database in place, which would be way more efficient. And it'd make it a lot easier to code because you wouldn't have to worry about some of the updates that come. But I haven't got there yet. Okay, so that's all the tech stuff. And the rest of it is examples. So I said last summer I worked on I had a pre-existing app that I wanted to add some cloud stuff to. So this is a product called Curl Coach, which has been on the market for about 3 years now, a little over 3 years. And it's used in the curling field. And it's used by coaches internationally to help manage their teams and do all the statistics and practices and do team development and all that kind of stuff. It's a pretty successful solution. It's on iOS only, and I've actually had multiple coaches tell me that they had to buy iPads so they could use it. And I usually said to them, great, so you gave Apple several $100s, so you could give me $40. But anyway, it already had a JSON-based solution for sharing content. That was just fortuitous. So there was an ability inside Curl Coach to export large amounts of the statistical stuff and share it with other coaches who were also using Curl Coach through mail, essentially. So I already had a JSON-based solution for wrapping up all the data I had and exporting it. So that fit into Meteor rather well. So it was really simple for me to build a server-side Meteor implementation to enable streaming. And in fact, the very first version of it had no web presence at all. It was just server. There was no client. And I was streaming content to it, and then I had another app that was pulling the content out and native iOS displaying it. And later on, I added a web page. So this one, really, really simple, right? It's actually, I think there's like maybe more than 4 now, but basically there's 4 collections in this whole thing. One that holds the competitions, and for a given competition, all the games that were played for that competition. Within a game, the ends. Within an end, the shots. That's it. And they all have like pointers back to each other, so I can ask an end what game it's in. You can ask a shot what game it's in, so that you can connect everything up properly. And to subscribe to this, the user goes in and can see a list of the competitions, and from the competitions they can pick a game. And then when they say, I want to watch this game get played, and it basically goes and pulls the first end and then it subscribes to all the rest of them. So once the first end's ready, it can actually start replaying the game. And then the reactive part was, if somebody was live charting a game, you could still watch it. And as new shots showed up, they were automatically brought up to the client. And fully reactively, you could watch a game and stream it. Okay. So fairly simple web front end. I can show you it. At that point, I didn't really have much of a collection manager, and I totally didn't need it because Curl Coach was 100% pushing content. It didn't really care about the collections. It just needed a bunch of Meteor calls to shove data down to the server. So that's what I did. So let's see, can I get there? Where's Chrome? Okay, so this is Curl Coach. Sorry, this is Live Stones. And all of this is canned content, meaning this was streamed live, but nobody's curling right now, right? It's too warm. So here's an example of a bunch of stuff. And if I grab a game, okay, so this is pretty much pulled down the whole game by now. Sorry, let's scroll this, right? But this is fully reactive. So if this was a live game that was in progress, there'd be another button that says go live, and it would automatically skip ahead. This is all just done in Bootstrap from a UI perspective, except for the curling sheet, which is HTML5. It's a canvas. So all the rendering is done as an HTML5 canvas. This stuff is all Blaze and Meteor. That's just, yeah. And the sheet, which is doing all the animations, is an HTML5 canvas that's being fed the data through Blaze. This one actually uses a live listener so that when new shots appear, it knows how to stick them in and decide whether it needs to trigger another animation. So it's doing that kind of stuff. And there was a chat, which obviously is not happening right now. There's a chat window that people could chat back and forth. Yeah, the coaches are actually already doing that. Right? So the way Curl Coach works is you see the targets are sort of showing up. Should be, yeah, see the target just showed up, and then it disappears as the shot animates. The coach actually says, this is where the rock's supposed to go, and this is where the broom was, and this is what happened. They drag the rocks around. And Curl Coach is doing all sorts of like deep statistical analysis of what's going on in terms of scoring shots and what kinds of shots were being played and all that kind of stuff. But also it has this ability as a result of that to replay. So Curl Coach has always had this ability to replay the game after the fact. So all I really did was webify that, right? And it turns out that when HTML5 Canvas guys wrote the spec for how you do rendering, Apple pretty much did it for them. Because you can one-to-one map core graphics, APIs, to HTML5 Canvas. Right? When I wrote the Canvas the first time, I literally cut and pasted Objective-C code into JavaScript and then changed the syntax. But it's the same calls. So that's makes it very, very simple. Okay, so that's it. The actual basic streaming stuff I had working in 2 days. That's the Objective-C DDP side of it, to actually push the content out, and the server to actually be able to read it, and another client to actually play it back. So it was remarkably fast and easy to do, which is kind of the goal of ObjectiveDDP, right? Or of Meteor. Okay. IDrive's a little more complicated. So this is text that we're going to be reworking. But iDrive is a social media platform that's designed to make it easier for people who are trying to get together with friends to actually organize that kind of stuff. So, with people on email and instant messaging and phones and just not reachable and all the other kinds of things, the idea of getting together 4 or 5 people or 6 or 7 people or 10 or 20 people and getting them to all agree to a time, place, and an actual event, it's hard, right? And sometimes it can take more effort and more time than the event itself. So iDrive allows you to create an event and attach a number of options to that event and a bunch of invitees to that event, and then announce it. And all the people who have been invited are basically asked to come in and take a look at the options, and they all get a chance to vote. And those votes are, in the simplest form, they can be a thumbs up, thumbs down kind of voting. And in the more complicated form, it could be, I love this, this is okay, can't do this, won't do that. So you sort of got 5 levels of preference there. We use all the reactive stuff so that if you're the organizer and you're actually watching your event happen as people vote, the graphs, you get live graphs that keep changing as the votes come in. You can see all the votes in real time. You can see who's actually looked at it versus who's actually voted and get all that kind of data. And then as you see a consensus forming, you can pick one of those options and say, this is the one we're going to do and confirm it. And then iDrive will send out a new round of communication saying, this is what's happening, please RSVP. And it tracks all that stuff back to you so you can know who's going to be there and who's not going to be there and all that kind of stuff. It works extremely well, and it uses Meteor like crazy because we like all the reactive stuff and the ability just to track all the data that we need. So it's a traditional Meteor design. It has 14 collections in it right now. So that's a lot, at least I think it is. All interlocked. It was designed Meteor first, and then the iOS client was added later, so quite the opposite of what I did with the curling software. Upon login, subscribes to almost everything needed by the user. This is in the iOS version. So essentially, when you log in and we have your credentials, we go look at all the events that you're part of, whether you own them or whether you're invited to them, and we suck in everything related to that so that from then on, you've got it. As opposed to like, I navigated to this page and that means I need to pull in the avatars for, I don't do that. I bring it all in. We're looking at caching some of the large content. So in particular, the avatars, because they're the single largest data objects that we ever deal with. And they don't change that often. So it's not that big a deal to store them locally and do a 2-stage subscribe, where your first subscription basically gives you IDs, maybe text names, and a timestamp that says this is the last time it was changed. And then internally you go, oh, the version I have is older than that, resubscribe, but give me everything. Or I have the current version, don't bother resubscribing. And then you can filter the amount of data that goes down the pipe because you've got a local file store cache, right? So that's future. So has native integration, native UI that we found really difficult to do with Cordova. Easy access to context, calendars, photo library, and user permissions to do all of that. Full-on push notifications. It will be easy to enable in-app purchases if we need to do that. It should be relatively easy to do offline mode. So a lot of the things that I talked about as pros at the beginning were things that we really needed for this product, and that's one of the reasons we went here. Right? Okay, that's my content. All right. I can show iDrive the web client. Larry's got the phone version, the iOS native version on his phone. So you can actually see it if you want. And if you have questions about any of the stuff I talked about or you want me to go back and cover something in more detail, I can do that. Okay?
The collection manager, you wrote or it's packaged?
Totally wrote it myself. Yeah. And the thing I actually did between the last Meteor meeting and now was I went back and looked at it because we talked about whether I could present it and it would make sense. And I spent maybe 2 days going, okay, this little piece of it really is specific to my project and it doesn't need to be here. Right? So I abstracted it out. So I actually have another layer right now sitting on top of the collection manager, which is iDrive's data model manager that does a few other things that iDrive needs, but that would not make sense in an open source library that makes Meteor easier to use on iOS. So it's pretty clean right now. About the only thing it really needs you to do is define that set of SQL objects that handle a user, right? Because it wants to pull your user in for you, and if you don't have those, they're not going to convert. So it actually does include the user definition, and that's about the only external file that you'd need to create before you can actually compile and run this stuff. Yeah, other than that, it should just all work. Yeah?
So if you pull down a Mongo, if you get an object that has nested subdocuments.
Yeah, and trust me, iDrive has tons of them. Yeah.
Do they get separated out into? I think you mentioned that.
They get SQL, right? So SQL means you can't have an array in SQL. It doesn't know how to deal with an array. So if you have an array stored in a Mongo object, you have to create a relationship to an object that has a back pointer to your first object and has a single entity in it, which is the thing you're storing in the array. So you do that. And you define that in the mapping model. It says this child object is called this, and you can build it out of the database with this name. And in that particular case, where it's really a singleton, there's actually a keyword that goes into the map saying it's a singleton, just assign it. And then the engine just does it for you. Now, I looked at building the converter that goes the other way, right? Basically rip all the stuff out of core data and create the dictionary for you. And it turns out it's a lot easier just to write the dictionary code, right? To write an object that extends your core data object that creates the dictionary and passes it back. That's
Set it as JSON.
yeah, well, you have to do it as JSON, right?
So I was going to ask you, it's not this one way, right? It would go back.
It's JSON in both directions.
Okay.
So the stuff I did with the curling software when I first did sharing, I had code that would say, here's a competition object that's in core data. Give me the dictionary of it. And it would create a mutable dictionary and shove all the data into it and pass the dictionary back to you. Okay. And then I would take that dictionary. When I was doing sharing between users of my software, there's a library inside iOS that is a JSON serialization library. You give it a dictionary, and so long as everything in there is JSON serializable, it gives you back an NS data object, which is the JSON of it. And then you can, with an NS data, you can do anything with it. So at that point, you could write it to disk. You can shove it across a pipe. You could shove it across a REST API. Or in my case, since I was just mailing it between users, I'd open up an email and make it an attachment. It's fast, right? I didn't need, with ObjectiveDDP, the JSON serialization is happening inside ObjectiveDDP for you. They're using the same library, but you don't have to worry about it. Okay? Anything else? That was easy.
Awesome.
Okay. Chrome, where's Chrome gone?
So would you, I think you would start another app again, do the same thing?
So,
Build another mobile?
well, yeah, there's that, do you start from scratch? So I sat down with some people. There's back up a little bit. So there's a new format for junior curling being brought into Ontario by some people. If anybody follow curling at all? A little bit. So you know what the slam is, right? That slam is like professional curling in Canada, and it's a particular format. Although it's a format they keep juggling, but nonetheless, it's elite teams playing a very competitive game, but not under the auspices of the Ontario Curling Association or the Canadian Curling Association. It's just it's competitive curling for money, basically, and it's a different kind of competition, and it doesn't exist anywhere in Canada below the adult level today, which basically means all the kids who are learning are curling under the provincial rules or the national rules, and they really don't get any exposure to the slam format at all. And in theory, they're supposed to be becoming really good curlers so they can compete in it. So a couple people in Ontario are bringing a slam, two of them technically. There's an under 18 slam and an under 21 slam, which are the two different junior formats. And they have events running next year. So I'm working with those guys to provide the streaming for it. So basically coaches who, like a sponsored thing, so I get some promotion out of it. But any coach who is using my software already at the slam will be able to stream those games for free through my servers. And at the same time, if you want to stream all season, assuming I get it done over the summer, you'll be able to do an in-app purchase, like a subscription model thing. So I can generate some recurring revenue against my curling software, and people will be able to stream anywhere in the world all year for not very much money. So, and there's some other stuff I'm going to be doing for the slam. One of the things that they're missing right now that they desperately need is live scoring. So, be able to go to a website and see what the scores of all the games are, which is like no data. A game is typically 8 ends, 2 teams. So you have a score per team per end. One of those scores is going to be 0, right? So looking at 16 numbers that I have to reactively serve per sheet in play. There's 4 sheets in play. There's no data there, right? So this is like a trivial enhancement, and I'll use the exact same server I'm running Livestones on and give them that ability, and it'll all be branded my stuff. And my long-term goal there is prove the technology works for streaming curling games in time for the next Olympics. Because there's a couple of networks that I know are interested in this stuff if I can prove it right and make the right pitch. I can actually make some money off curling for a change. Remarkable. So that's kind of what I'm doing with that. And most of my other efforts in terms of Meteor are focused on this. Right? This is what I spend most of my time on. And any other contract work I'm doing is, it's the client tells me what they want to do. Most of that's iOS, native.
So is IDrive, is it public yet?
Well, so a month, I'm going to let you talk in a second. A month ago, if you'd gone to the www.idrive.com website, you would have seen something horrible. It was a color test for our logo that I put up over a year ago when we were arguing over what color the logo should be, and with a coming soon at the bottom of it, which was like one of those, that's wrong. If you go there now, as of about a week ago, you actually get useful content that is relevant to what we're trying to do. Now, this is not a Meteor site, because it doesn't need to be, right? Right, so this is your basically marketing backend for a startup. Sorry? Oh, okay. Okay, I didn't want the pop-up. There we go. Right. And there's stuff on here. So if I go back to the banner, right? There's an about, which is text that we know we're going to rework, and there's a beta program, which we're just in the process of launching. So there's information in here about how to get to the beta program, which basically means sending emails to the system will let you send emails to us to say you want to try, and then normal legal and send us an email stuff. So that's where we are. We're right on the edge of actually going, putting this in people's hands other than friends and family dog fooding it. And the primary goal of this is to have open ears, to have people tell us what works, what doesn't work, what it really needs to be able to do. Have you thought about using it in this market, that market, whatever, right? And we're going to be, we're in the middle of working with Ryerson University to try and get a whole bunch of students testing it, because we think our core demographics are those guys and new grads. But at the same time, a colleague of mine who's in Colorado, of all places, she's been playing with it or an ex-colleague of mine, I guess. She's been playing with it for a little while. Mostly she sets up not suitable for work gaming nights with her alumni coworkers, where they go to bars and play Cards Against Humanity and Exploding Kittens and stuff like that. And she's got a pretty big invite list that she needs to filter down to who's coming. But she also just turned us on to another friend of hers, also in Colorado, who's with a not-for-profit charity group, and she's doing big luncheons for volunteers, and her invite list is like 100 people. So that'll be an interesting stress test, because we're going to have really fairly big data sets compared to what we designed for. Right? We were designing for invitee lists of 20 and under. And there's nothing about the design that will stop it from working with those big numbers, but it'll be interesting to see what actually happens. So we're there. We're going to see what happens with the deployments that we have in terms of whether we run into performance issues or not, with the UX that we have and where it can get better, and we know it can get better, right? Because it's early. It's that kind of stuff. It would also be interesting to say this. So iDrive is currently deployed on Galaxy at their cheapest tier, with a free MLab tier behind it, right? We're nowhere near the data that we're going to run out of MLab space, and while we know there's performance issues with the free tier, we'd like to see how that actually plays out in the real world. And Livestones, partly because of last month's presentation, Livestones have been mothballed because it was on the free Meteor tier last year. And I brought it back to life 2 weeks ago. I've got a free tier MLab, and I use so little data and little data transfer, I'm not worried about performance at all there. And it's up on Heroku. So that's deployed on Heroku on their free tier. So it's completely free right now, which is great. So I can tell you a little bit more about, there was some questions last month. So Heroku's free tier, you can have your app can be up for 18 hours out of 24 without running into charges, which is not going to be a problem for me. And I think their tier that gives you 24 hours coverage is like $7 a month, so it's not bad. And if you want to CNAME into it, so if you want to have your own URL, like I do with Livestones, as opposed to a Heroku URL, you have to register so they can charge you. So you have to give them a credit card, which a lot of people seem to not want to do. But the actual CNAMing is free. It's just so that you can actually tell Heroku to expect this URL to come to them, and they're good with that. And there's some build packs, but most of them expect to have the MLab build pack sort of built into it. So if you've already set up your database side, which I had, some of the build packs, like Horse, is considered to be the best, but Horse really falls down if you've already got your database set up, because it really wants to provision your database for you, and turning that off is not trivial. So anyway, I ended up not using Horse. I tried for about a day and gave up. So I used another one. So I've got a little bit of experience in deploying in various situations.